So we're going to prove pretty famous limit, the limit of trig functions. The limit as a goes to 0 of sine of a over a is 1. And the proof is a geometric proof. Now, since the angle is approaching 0, that means it'll be a little bit positive or maybe a little bit negative. That is, it'll be in quadrant 1 or 4. And we're going to look at the unit circle. Okay, we're going to look at the unit circle. That means R is 1. Oops, that's not a radius. The radius is 1. Now, we're going to look at 3 different areas. Now, if this point here is xy, this is xy. But I don't really want it in terms of x and y. But it is what it is right now. It's xy. Now, if I were to draw this triangle, and this is angle A, well, and the hypotenuse is 1. It's one of their many radii that the unit circle has. Now, if you look or you consider the cosine of A, well, it's the adjacent, which is x, divided by the hypotenuse, which is 1. Oh, cosine of A is x. That is, I can replace x with the cosine of A. And there's a y next to it, but let's look at this for a moment. What is the sine of A? Well, it's the opposite divided by 1. It's just the opposite. But this height is y. That is, I can replace y with the sine of alpha. Okay. Now, I want to get rid of that line for a moment. Now, what is the area? So let me get rid of this too. What is the area of this triangle? What is the area of that triangle? Well, like every triangle, it's 1/2 times the base, which is 1, times the height, which is sine of A. Now, since this can be going on in quadrant 4 as well, let's make sure that the sine of A is positive. So, we just found out what the area of this is. But you know what? I want to go a little bit further. Let me just draw this on. I want to add on that area as well. I want the area of that whole thing. Well, I know the area of the entire circle is pi times r squared. It's pi. But we only want part of pi. What part of pi we want? We want theta out of 2 pi of that. This cancels out. You get theta over 2. This is less than or equal to theta over 2. It might be more because we added on that piece to this piece. This piece was that, and then we added this on to get that. But we have to be careful. Let's take the absolute value of it. Now, this is going to be less than the area of yet another triangle. The other triangle is this one. It's that. Now, what is the tangent of A? Well, it's the opposite divided by the adjacent. But the adjacent is 1. That is, the opposite is the tangent of A. So let's just write that. This height is the tangent of A. And the area of this triangle, like any other triangle, is 1/2 times the base. The base is 1 times the height, which is tan A. Well, 1/2 times 1 is positive. Let's make sure that this inequality is also true in tangent 4, in quadrant 4. Okay. So the first thing I would do here is I would multiply by 2, which kills that. So now we have 1 times the sine, the absolute value of the sine A, which is just that, divided by, less than or equal to, I'll apologize, this is angle A, which is less than or equal to 1 times the absolute value of tangent A, which is just the absolute value of tangent A. But I'm going to write that as the absolute value of A divided by the absolute value of cosine A. Nobody would deny that. Now I'm going to divide by the absolute value of sine alpha. And the reason, and I don't have to worry about changing the directions because it's positive. And remember, the angle will never be 0. Okay, so we'll be around here, but not 0. We remove that piece. Probably a more appropriate graph would have been near 0. Goes like that, goes like that. Okay, that's where we're at. Angle can't be 0. That is, it's either positive or it's negative, and when you take that absolute value of a positive number or a negative number, you get positive, never 0. Now I see one thing I didn't do. I divided this by the absolute value of sine theta. I divided this by the absolute value of sine theta. Now, over here, in the third place, it's not very friendly to divide by sine theta. So, you know what I'm going to do? I'm going to multiply by the reciprocal. Now, in here, this is 1. In here, we have this. And over here, we have 1 over alpha. Now, everything here is positive. I mean, this is bigger than 1, and this is even bigger. So we have this property. If A is less than B, and even less than C, then, starting from the right, 1 over C is less than 1 over B, which is less than 1 over A. And if we have equality, we have equality. So I'm going to use that rule right now. The reason is I want to get the reciprocal of this. I mean, after all, look at what I want to prove. Okay. So I have 1 over, I have the reciprocal, absolute values. I have the reciprocal of that, which is cosine alpha is less than the reciprocal of the middle. which is less than or equal to the reciprocal of 1, which is 1. Okay, now we need to look at this more carefully. Let's talk about the cosine of an angle near 0. The hypotenuse is always 1. So we can have angle A here, or we can have angle A here. Now, the adjacent is always positive. You're going to have positive over 1 in quadrant 1, and in quadrant 2, you're going to have the adjacent is positive divided by 1, which is positive. So anywhere near 0, we don't need the absolute value bars. Okay, now let's look at the sign. So, in quadrant 1, the sign is the opposite over the hypotenuse. Okay, so in quadrant 1, the sign is positive and the angle is positive. So the whole thing is positive. Okay, now in quadrant number 4, the sign is the adjacent over 1, over the hypotenuse, which will be negative. So, in quadrant 1. In quadrant 4, the sign of the angle is negative, and you know what? The angle is negative. Well, that fraction is going to be positive. No matter which quadrant you're in, 1 or 4, sine of A over A will be positive. Now, I guess to be really exact, I can say that the sine of A, the absolute value of sine A, divided by the absolute value of A, is the absolute value of sine A over A. But in quadrant 1 or 4, that is always positive. So I do not need the absolute value bars. So now I have that this function, which we want the limit of, is jammed between those two. Well, I don't really want this function. I want the limit of that function as A goes to 0. So I take the limit of all three sides. The limit is A goes to 0 of cosine of A, which I know is less than or equal to the limit as A goes to 0 sine A over A, which I don't know. If I knew it, I wouldn't have done all this work, which is less than or equal to the right side. The limit as A goes to 0 of the right side. Well, this limit is just cosine of 0, which is 1. The middle one, like I said, I don't know. I do not know what this is. Less than, and this is a constant, so as the angle A changes, the constant stays the same. And then I'm done. This thing is jammed between 1 and 1. Can you think of any number? Can you think of any number that you could put in there that makes this true? And there's only one answer, 1. And if this is what's in between, it must be 1. So, the limit as angle A goes to 0 of sine A over A is equal to 1. And it's not because the teacher told you it's true, it's because we proved it. That completes this video.